Hello, welcome. Today we're going to be doing some Kotlin together. I am Sebastiano, I work at JetBrains, but I'm going to have a lot of opinions, and they're not necessarily JetBrains opinions, just FYI. They're my opinions, and I have a lot of them. So before we begin today, as I was mentioning earlier, make sure you have a computer. The talk part, which is about 25 minutes, you don't need a computer for. You can just stare at me awkwardly. But then after that, to do the actual workshop, you kind of need a laptop. You should also make sure that you have an IDE installed. Sounds obvious, but you would be surprised. So IntelliJ Community works, Android Studio works, whatever you prefer is fine. Make sure it's up to date. Make sure that the Kotlin plugin is up to date. Now, as you will realize, we are at a conference. Wi-Fi might or might not work. If it doesn't work, good luck. Maybe you can hotspot, I don't know. But if you have everything ready, it shouldn't be a problem. There's only one thing that you will need to know, which is cloning the repository. I'm going to leave that URL on the screen so that while I talk, you have about 25 minutes to clone the repo, which should be enough even for conference Wi-Fi, hopefully. You will have about an hour-ish to complete the exercises. I know that the abstract is about Kotlin, but this workshop is as much about Kotlin as it is about testing, because the clone, once you clone the repo, you will find that you have a number of exercises that will cover the topics that we talk about in the introduction, and there are tests for them that you can just run. And your goal is to make them green. Now, there is no expectation that you finish everything in the hour that we have, because this is calibrated for about 2.5 hours. So don't worry if you don't finish everything. The nice thing about the tests is that you can finish them by yourself. If you have any doubts or problems, you can hit me up on Twitter. I can help you with stuff, no problem. Or later today or tomorrow, I'm just going to be around. So, okay, everyone. You got that? Anyone in trouble? Just say, ah! Okay, that was like, I'll give you another 20 seconds. 19. I'm gonna have the link again at the end, don't worry. I'm just gonna start, because otherwise we just waste the whole slot. Okay, so we're gonna talk about a number of things today, a number of advanced construct in the Kotlin language, but I think it's a good idea to start small, start with the easy stuff. So what about properties? We know what properties are. They are the things that are inside of a class or outside of a class, and they start with val or var. What's the difference? Well, val, you probably know, is like final in Java. It means that you have an immutable reference, which is inside of that, the content might change, but you're always pointed to the same instance. But you don't really know what's going to happen, because if you have an immutable reference to a mutable class, then there's no guarantees about the value still being the same over time. On the other hand, you have vars, which are, everything is mutable, including the reference, meaning you can reassign them. What happens when you want to have a property, but you don't have the value to begin with, and you know you're going to get the value later on, but you don't have it at the moment you're instantiating a class? There are several ways you can handle that. One of them is using late init. So late init is essentially a construct that is telling the compiler, trust me, I know what I'm doing. I'm going to give you a value at some point before I try to read it. So it's on you to make sure that the value is populated before you actually try to access it. And it can be more or less complicated. There are some very clear use cases for this kind of stuff, such as dependency injection, like Dagger, or if you need to populate values that depend on having a context on Android, for example. So you need to wait until you are on create before you can actually create the value that you need to assign. The good thing about late init is that it doesn't have essentially any overhead at runtime. It's very cheap to use. And it's a var, so you can still reassign it later. You can change the value, but you don't need to initialize it when you declare it. Now, the fact that it's a var is also the reason why most people don't like late init. You can, though, check with late init if it has been initialized since Kotlin 1.1. There is an isInitialize property on the property reference. I'm not going to make it much easier than this, right? The one limitation of late init is that you cannot use it with primitive types. If you want to use primitive types, you can use a property delegate, which is called not null, and we're going to see in a second what a property delegate is. We have another scenario, which is we have a property, we have something that we know is expensive to create, and we don't want to do the work unless it's strictly necessary. So late init, you probably always will populate the value, it's just later on. But maybe you have a database connection that requires time to open, or some resource that is expensive to hold. Maybe consumes memory, maybe it takes time to compute the value. In this case, the idiomatic way in Kotlin to handle this case is using the lazy delegate. Now, lazy takes a value that, takes a lambda that produces a value, and the idea is that whenever you first access that property, that lambda is executed, and it's only ever going to be executed once, and the value is cached for the rest of the execution of the scope of the property. One important caveat that a lot of people don't know about is that lazy is by default synchronized. That means it's thread safe, which is good, but it also means that it is somewhat expensive to access at runtime, because every time you access the value, you're actually getting into a synchronized block. If you know your Java, synchronized block is a way to make sure that there's only one concurrent access to something. And that has a non-zero cost. So if you're accessing something on a hot path that is by lazy and is the synchronized version, that's going to cost you some performance. There is, however, a way to make it less expensive, which is to use to pass in the lazy thread safety mode none, which means pretty much hold my beer. But if you do that, you are kind of falling back to the same situation you were with late init, where you need to make sure that you only ever access the value from one thread at a time. So your threading becomes important, and the order of access becomes important. Okay, that was properties. Let's move on to the type system. The type system in Kotlin JVM specifically, inherits the limitations that type systems have on the JVM. The biggest limitation there is on the JVM is type erasure. What does that mean? Type erasure means that when you compile your code, in the class file, in the bytecode that is generated, the information about the generic parameters is lost. And that means that once you're past the compiler and you get to the runtime cannot help you make sure that you're not using the wrong type. So you're more prone to have cast exceptions or stuff like that. In some regards, the type system in Kotlin is a bit stricter than it is in the basic JVM Java type system. For example, you have explicit covariance and contravariance, which you express with keywords that are in and out. Now, probably you're wondering what the shit is contravariance and what the hell is covariance. Well, it's complicated, and most of the time you don't really need to care. There are some cases when you do, so 99% of the time you don't need to specify the in or out keyword, you're going to be fine as it is. But sometimes you do need to specify that. And it's also complicated. My suggestion is just try one, try the other. It's going to work at some point. Very professional. But like realistically speaking, there is very clear documentation on the Kotlin Lang website about covariance and contravariance, and it explains why it's in, why it's out, the meaning of all of that, and I recommend you go and read that. I do read it periodically. I have the problem that I forget it after 30 seconds, so that works. Another nice things of the Kotlin type system are reified types that you don't get with Java and generally on the JVM. Reified types are only available for inline functions. And there's a specific reason for that. So reified types are sort of a workaround for type erasure. It's some magic that the Kotlin compiler is doing for you by kind of keeping track of the type parameters after it's actually theoretically being forgotten by the bytecode. And this allows the compiler to resolve type parameters that you're passing to your functions. So if you have used a Java API that takes generics, you've probably seen passing, you've probably had to pass the class as one of the parameters to a function, because that tells the compiler what the actual return type will concretely be at the end. And with reified types, you do not need to do that anymore, because the compiler is smart enough to say, oh yeah, it's that one, I know that one. And the only reason why it works with, in this case, and the reason why it only works with inline functions is that the compiler is smart, but only smart to the point where it knows that it's essentially copy-pasting your code into where it's called. Well, that's what an inline function is. It's just saying, oh, that function bytecode, I'm just going to copy-paste it into where it's used. Another advantage of reified types when you need them is that you don't necessarily need to specify type parameters explicitly in most cases. There might be some where it's still needed, but you're probably fine without. Next topic, another exercise you're going to see in the workshop later, is about enums and seal classes. If you have seen Ivan's talk this morning about domain modeling, that's what you use most of the time to do domain modeling, right? Enumerations, probably everyone in the room knows what they are. The old Java enums. They are enum classes in Kotlin. I would be surprised if someone has never used them. They work exactly the same as Java. So Ivan hit this, I hit that. At some point, we're going to demolish the room. On the other hand, seal classes, they are essentially kind of the best of both worlds, because you have the sealed hierarchy, the closed hierarchy that you get with enums. That means in human language, you know exactly what kind of values you can have. But you also have the ability to attach some data to those instances. Because enums, they're statically known at compile time. You cannot attach data to it. But seal classes, you can. And this allows you to create a domain model that makes sense and allows the compiler to tell you, hey, you forgot that case. Now, when you implement a seal class, you can use objects, you can use data classes, you can use value classes, whatever you want. You can mix and match according to your needs. The main use case, again, for seal classes is the idea of, hey, I need an enum for types, so it's a closed enumeration of types, but I also need data with them. And an example of them is Kotlin.result, or either, I think as well, that is an arrow, that kind of stuff. Okay, functions. Member functions are the kind of functions that you put in a class, you know. Extension functions are functions that you apply to a class that you don't necessarily own. And that's one of the advantages of extension functions. You can create an extension function for code you don't own. Say you don't like the ads SDK that you're using and you want to have to make your life easier, you can create and define an extension function that will do some machinery under the hood for you, attaching it to third-party code. and even when that code is final and the classes are closed. Now, to make that happen, because you cannot make it too much magic under the hood when it comes to it, it is statically dispatched. What does that mean? Do you remember what static methods are in Java? That's the same thing. Under the hood, that extension function is translated to a static method in the Java bytecode. And what looks like in Kotlin is on the left-hand side, you have any class.myFun. When it's compiled, if you decompile it into Java again, what you see is that you get a static void myFun that takes the receiver as the first parameter. And if you have other parameters, they're going to come after the receiver. But functions don't necessarily need to be inside of a class. They can also live outside of a class in a file. You've probably seen them before. You've hopefully used them before. Those functions are called top-level functions. They also translate to static methods on the JVM. Now, the JVM does not know how to deal with a function or a method in the bytecode that is not attached to a class. So what the Kotlin compiler does under the hood, it generates a synthetic class that is named the same as the file that you put the function in. So for example, if you have a file that is called funcs.kt, the synthetic class will be called funcskt. And functions can take other functions as parameters. That's a very important and very powerful concept of functional programming that you have available in Kotlin. If you want to sound fancy, you can call them higher order function. Otherwise, you can call them functions that take lambdas as parameters. And one of the things that higher order function provide you is the ability to create DSLs. What are DSLs? DSLs are domain-specific languages. That means that you can write some code that makes dealing with a specific aspect of a domain in a more concise manner, in a clearer manner. What you do is you take advantage of several ideas that we've seen so far. So for example, you use extension functions to define what scope a DSL function applies to. And then you can use higher order function to compose behavior. So for example, you can take in your function a lambda that you can use to configure an object that will then at the end be emitted by the DSL. An example here would be you have a function that is called user that takes a block that has a receiver of type user and returns unit, so you're not supposed to return anything. And that user function emits at the end of its execution a user instance. And then the way you would use it in the code is you would say, oh, I want to create a user, so it's like user, curly brackets, and then you configure it inside. And assuming that the user object has a name, first name and last name, then you just assign it as if it were a property, because it is. I mentioned functional code. Kotlin is primarily an object-oriented language, but it also has functional facilities. What this means is that you get stuff like top-level functions that we just mentioned. You get function types and you get lambdas, so you get higher-order functions. You get a number of APIs that you don't get in the JDK for processing collections that are super useful, because when you do functional programming, you're very often handling pipelines of data. And then you have concepts like sequences that are essentially like Java streams, but they're lazy. And they, just like streams, they can only be played once. Playing means that you can only iterate through the sequence once. If you want to play it again, what you do is you create another sequence from the same source. That can be a list, that can be anything really. Another important concept in functional programming are pure functions. Pure functions are normal functions. They're like normal. Again, making up functional names, but it's fairly straightforward. The idea is that a pure function does not depend on any global state, so it doesn't reach out to read anything that is not passed in as a parameter. and it does not have side effects, which means it doesn't write anything anywhere. The only thing it can do is return a value. Now, if you do need to have side effects and you're doing functional programming, what you want to do is you want to move the side effects to the boundaries of your system so that they're isolated and you can world in your idyllic functional world elsewhere in your code base. This is great. Functional is great for some applications. For example, if you do a lot of data processing, it's excellent because having pure functions, for example, allows you to have a predictable behavior because of the way it's defined. Given a certain input, the output will always be the same because it doesn't depend on anything else. So it's 100% deterministic. Another example here related to data processing is pipelines. So you can have, probably everyone here has used at some point RxJava or flows, stuff like that. Like that kind of stuff is functional programming. And it works very well, as you know, for handling a big amount of data and doing complex manipulation. When I mentioned earlier the collections API, the ideas are the same that you get in functional programming. Again, if you've done Rx or if you've done flow, coroutine flow, you know the basics like map, flat map, filter, group, usual stuff. Kotlin also provides some more APIs on top of that for different types of collections. So for example, for lists, you get things that are related to the way lists work. So you have a way to get just a sublist, you have a way to get an item by position, you can do binary search, that sort of stuff, because they're ordered and indexed. For maps, you have functionality that is aware of the difference between map keys and values, and you can also iterate over the pairs that make up a map. For sets, you have the set operations, intersection, union, subtraction, and so on. And all of those things are there, and you probably have used them before. You just didn't realize that, oh, wait, that stuff doesn't really exist in Java. Huh. So another interesting thing that you can get with Kotlin are the structuring declarations. They are special functions that are called component and then a number that goes from, I think, 0 to whatever. The idea is that if you have parameters in your primary constructor, when you create a function that is called component n, it's essentially a getter for the parameter number n in your constructor. So component 1 is going to be the first parameter, component 2 is going to be the second parameter, and so on and so forth. Now, it's tedious to write that stuff by hand, so data classes are there for that. Data classes will automatically get component functions generated for you under the hood. And that's great because then what we can do is we can start using the structuring declarations. The structuring declarations are an easy way to unpack a class set of components and properties. So for example, going back to the user class we were looking at earlier, you have a name, you have a surname, you have an email, and then you can say, oh, I just want to get the name and the surname. So instead of doing val name equal user.name, blah, 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 you can do val parentheses name, comma, surname equals the class. And the compiler will unpack things for you. One noteworthy thing in this example is that we have not looked up the email. We don't care about that, so we just omit it. We can take up to the number of parameters we care about. And we can also skip the ones we don't care about by using the underscore. Okay, that was a lot, and now it's time for opinions. In a segment that I like to call Everyone Has Opinions, but I'm the speaker, so you're going to have to listen to mine. So extension functions, they're awesome. I love extension functions, but they're also terrible because they can be very hard to discover, especially if you're on GitHub looking at a pull request and you see someone calling something on an object, and you're like, what is that? Where is that defined? And then you find out that 15 files later, oh, that's the thing that was doing. It's terrible. So the main reason why they can be bad is because they tend to break encapsulation, because you can make them live anywhere and you don't have an easy way to find where they live. So my recommendation is to avoid abusing extension function. And you're going to see a theme here of don't try to be too smart. Think of the next person that comes in and reads the code you're writing. And it's the same, treat them the same as util classes in Java. You don't want to have them unless you really have an alternative, because it generates spaghetti code. I'm Italian, I like spaghetti, but not spaghetti code. My personal preference is when I use extension functions, I start always from the smallest scope I can. So I make them private to the class or to the file that I use them in. And if I see that is something that I need more and more, I gradually increase the scope to internal, to public, whatever. But I never got to the point where I actually needed to make something public. It might be that if you have an extension function that is that useful to everything else in the project, maybe you should consider using something that is a bit more object-oriented properly, so you can create a class or something like that that handles that use case. There is an exception to this, which is if you have, as I was saying earlier, a horrible SDK that you're dealing with, maybe analytics, ads, all those things, they tend to have bad APIs, so maybe you want to write an extension function that kind of does the initialization of the library for you, just to encapsulate that code away. That might be a good use case, but then again, be cautious. You should also try to consider whether you can use a top-level function instead, so it's a bit more explicit what's going on, and it might be easier to understand. Lastly, extension functions look horrible from Java. Remember the example I did earlier where you have the static synthetic class? That looks like shit in Java. So what you want to do is, if you know that everyone is going to be using your code from Kotlin, fine. If not, remember that people are going to be using it from Java, and that might not be the best experience. Delegate properties. So again, they're cool, but don't abuse them. And the main problem for that is that I remember people telling me, oh yeah, so I've done this delegate property where under the hood, I connected the database, I fetch data, I commit a transaction. I'm like, wait, what? How can I tell that from just reading an innocent property somewhere? It's like, eesh. Yeah, don't do that to others, and don't do that to future you, most importantly. Talking about lazy, specifically, do not use lazy for everything. It has a cost. Even the non-synchronized version incurs a cost. Don't make things lazy that don't need to be lazy. Controversial, I know, but if you're just going for purely, I'll take care of it later, late init might be a better option for that. Or just a normal variable that you set the value for if you don't like late init. Now, when it comes to DSLs, you don't always need a DSL. 9 times out of 10, you do not need a DSL for what you're doing. Sometimes you do, but it's very rare. And I know that everyone thinks, oh, I'm in the one case. You're probably not. Statistically, probably not. Try not to be too smart, because you know what you're doing, but people cannot read your mind. So again, same thing. There's another thing that I haven't mentioned, but I just want to cover quickly, which is operator overloading. In Kotlin, there is limited support for operator overloading. That means that you can define what plus means for an arbitrary class. That sounds super cool, right? Don't do it. Because 99% of the time, adding two things together that are not numbers of strings is not obvious. It might have, people might have different assumptions about what happens. If I take my user class from earlier and I define the plus operator and I add two users together, what happens? Do they have a kid? I have no idea. So try to consider always, when you write code in general, that you do not want to surprise people that are using your code. You want to be as straightforward as you can and try to have intuitive understanding in your users. And if you do want to use an overload, make it increasingly importantly, very, very obvious that it's an overload. So something that you are 100% sure that everyone will notice, oh wait, that plus, yeah, Kotlin would never know how to add those things together, so that must be something custom. My reaction to that sort of situation is still, ugh, but your mileage may vary. With that, it's your turn. The link is there again. And I will be here and or going around if you have any questions on the exercises. There is no specific order for the exercises. You can do them in whichever order you prefer. You can skip the ones you don't like. There are difficult ones at the beginning. Well, not the first one, but there are difficult ones earlier on. So just don't worry. They're not increasingly difficult. They're in a very random order. Thank you.